Chapter 13, that means ASAP, and that means physiology as simple as possible. Again, here we go. Last time we were together, as the sun was fading, we had gone through all this marvelous stuff over here about the basal nuclei, the diencephalon, the amazing hypothalamus, the midbrain, the medulla, the cerebellum, even to the point of talking about what happens when a person becomes intoxicated and loses their sense of body sense. But ever so quickly, let's come back here and remind you of things you already know, and that is when it comes around to your central nervous system, peripheral nervous system, how they're plugged in together. In our schematic that we've used before, here is the input, peripheral nervous system, afferent or input, sensory. Here is the central nervous system with sensory, associative, and motor regions. And then over here is the peripheral nervous system, the efferent, output, or motor section. As a just quick wrap up and summary, you have exteroceptors looking at your somatic information, where your body parts happen to be. And there were receptors like mechanoreceptors, thermoreceptors, chemoreceptors, photoreceptors, and nociceptors, trying to let you know where your body parts are at. Visceral receptors, interoceptors, include mechanoreceptors, thermoreceptors, chemoreceptors, and nociceptors, no photoreceptors. And again, it's telling about what's going on, say, in the content of your stomach or in blood pressure, chemistry, and things like that. So all this information right here is heading towards your brain. And remember, we said your reticular activating system, which goes through a structure called your reticular formation, which just happens to be up here in this general region right there. That reticular formation acts like a filter, and it blocks 99% of the sensory information from your consciousness, from your awareness. It filters it. So it's the difference between what you're thinking about and what kind of information is heading towards your brain, not thought about. Anyway, so it's about what are you conscious about? What are you alert about? So when you're asleep, this thing right here is blocking more than 99%. You're not conscious of hardly anything. However, things do sneak through. So sometimes in your sleep, noises in the room, motions and stuff like that may be incorporated into your brain, that is, into your dreams and such. And that's got all kinds of great implications to it. Over here, we have the limbic system, and the limbic system is part of your emotional filter. It can put an emotion onto something, and this is one reason why sometimes things that really don't deserve an emotion get it. So you might think of cinnamon as Christmas, and Christmas is wonderful. Or you might think of cinnamon as Christmas, and Christmas is horrible. It's up to you and your experiences. So your limbic system very often tacks an emotion onto something, whether it's reasonable or not. Here inside the central nervous system, again, you got sensory, associative, and motor areas, short-term memory and long-term memory. We mentioned how with a Gestalt attitude, you find patterns and you put names inside those patterns, and that's how you remember things. The patterns could be events of the day, morning, noon, night, or it could be moments of your life when you knew this person, knew that person. Or for many people, it's high school versus college versus military versus falling in love, young adulthood, things like that. So again, you create a pattern and you put things inside that pattern. That's where memories get stuck in place. This mnemonic right here is an example of a pattern in which we have input, processing, and output, and hopefully this will help you out later on when you're trying to remember the organization of the nervous system. Here in the peripheral nervous system, the efferent or motor part, output part, you have the somatic region, and then you have the autonomic. Well, the somatic, again, deals with body, and so therefore this is where you're controlling skeletal muscles. If you're alert and conscious, you have the ability to control most, if not all, of your major skeletal muscles, and that is potentially a voluntary action. For the autonomic nervous system, this pretty much parallels the visceral input over here, and here is where there is control over your body that you are not directly conscious of. You cannot control it, so that's involuntary. It's divided into the parasympathetic and the sympathetic nervous systems, where the somatic only goes after muscle, only skeletal muscle. The Autonomic goes after muscle and gland. So cardiac muscle, smooth muscle, exocrine glands, and endocrine glands. Other things we need to say something about ever so quickly. We mentioned it the other day, and that is you need to know the 12 pairs of cranial nerves. You need to know which 3 are obviously sensory. You need to come up with all those little ways in which you're going to remember it. Of course, remembering the Roman numerals as well as the so-called regular numbers. Know what each one of these letters refers to. Don't get the O's mixed up in the T's and the V's and the A's and such. So that is definitely going to be part of the test. Up here, just in the running out the door kind of approach before the sun goes out completely, epinephrine, norepinephrine is what we commonly call adrenaline. It's part of your fight or flight sympathetic reaction to things. More about this in chapter 15. But sympathetic effectors, that is things that are influenced by the sympathetic nervous system, that's where norepinephrine, epinephrine is released. Acetylcholine is part of your parasympathetic nervous system and your sympathetic, because at the ganglia, the first step in which they're sending signals towards their effectors, both the sympathetic and parasympathetic use acetylcholine. Acetylcholine also is used at the parasympathetic effectors. So, the parasympathetic uses acetylcholine at the first and second synapses. The sympathetic uses acetylcholine at the first synapse and norepinephrine at the second synapse. Alzheimer's. It turns out that when there is a lack of acetylcholine in certain regions of the brain, Alzheimer's-like features may show up. Serotonin. Serotonin has many functions inside the body, and one is to help with a sense of confidence and mood. A lack of serotonin may lead to a sense of anxiety or depression. Alcohol can affect the effectiveness of serotonin inside your system, and in low levels might boost it. Unfortunately, in higher levels, it might counteract it. Dopamine, before I mentioned, is found in large amounts in the basal nuclei, which is associated with gross motor activity, and a lack of dopamine in that region might be associated with Parkinson's disease. GABA is the most common neurotransmitter inside the brain, is commonly associated with memory functions. Glutamate is an inhibitory neurotransmitter, and it, just like serotonin, is involved in mood and a sense of calm. And a lack of glutamine may lead to a sense of depression. And endorphins, as we might have mentioned before, are commonly associated as a painkiller. Heroin has a molecular formula very similar to endorphins, so very, very strangely, you make a heroin-like substance in your brain to handle extreme situations of pain. I've run out of sunshine.